Good morning, students. The next topic of linear inequation is modulus function. The second name is absolute value function. The one is the same thing. So what is the modulus function? The sign of modulus is modulus x. Now the modulus gives two values, either x if x is equals to or greater than or equals to 0. Modulus x becomes x if x is greater than or equals to 0. But modulus x becomes minus x if x is less than 0. For example, the magnitude of 5 is 5, but the magnitude of minus 5 is also 5. So the magnitude of two different values, but answer remains the same. So this is the basic concept of modulus function. Modulus x equals to x if x is greater or equals to 0. Modulus x equals to minus x if x is less than 0. Now if modulus x equals to 2, what does this mean? Modulus x equals to either x equals to 2 or x equals to minus 2 in simple terms. Again, we can say if x equals to 5, x equals to 5, either x equals to minus 5. Again, if x minus 4 equals to 2, either x minus 4 equals to 2 or x minus 4 equals to minus 2. This becomes x equals to 6. This becomes x equals to 2. So this is a totally basic concept of modulus function. The next one is modulus x is greater than 5. Whenever there is a sign of greater than with modulus, what is the concept of greater than? Draw a number line. This is 0, this is 5, this is minus 5. If we move away from 0 in either direction, the magnitude always increases. So this is a very important statement. If we move away from 0 in either direction, so आपने एक बात याद रखनी है, जब भी साइन ग्रेटर देन का है आपने 0 से उधर जाना है in opposite direction. So this is 5. So away from 0, this becomes 5 to infinity. Another point, minus 5. This becomes minus infinity to 5. So the interval is minus infinity to 5 union 5 to infinity. Because when the sign is greater than with the modulus, we move away from 0 in both directions. So the magnitude always increases. For example, modulus x greater than 4. Greater than 4 means 4 minus 4. The magnitude of minus 4 is also 4. The magnitude of 4 is 4. The magnitude of 5 is 5. The magnitude of 6 is 6. The magnitude of minus 5 is again 5. The magnitude of minus 6 is again 6. So whenever we move away from the 0, the magnitude always increases. So now in this question, minus 4 to 4. So away from 0, this becomes 4 to infinity. This becomes minus infinity to minus 4. So minus infinity to minus 4, 4 to infinity. Remember one thing, whenever the sign is greater than with modulus function, always move away from 0. Away from 0. So the intervals becomes minus infinity to minus 5, 5 to infinity. In this case, minus infinity to 4, 4 to infinity. The next another example where the sign is greater than with the modulus function. Now infinity minus infinity 0. Now the critical points are 1 and minus 1. Now the sign is greater than. So we have to move away from 0. So this becomes 1 to infinity. This becomes minus infinity to minus 1. The next concept is the sign less than with the modulus function. Now the sign is less than. If we move towards 0 in either direction, the magnitude decreases. So whenever the sign is less than, we always tends to move towards 0. So minus infinity to infinity, critical points, center point 0, minus 1, 1. Now we move towards 0. So towards 0 means minus 1 to 1. After that 1 to 0. So the class interval is minus 1 to 1. Second example. If modulus x is less than 4, now center 0, critical points minus 4, 4. Again the sign is less than. So we move towards 0 in both directions. So minus 4 to 0, 4 to 0. So the interval becomes minus 4 to 4. So the basic concept regarding modulus is the sign. Less than sign, greater than sign. If the sign is greater than, we tends to move away from 0. If the sign is less than, we tends to move towards 0. Now here we start with some important questions related to modulus function. Now the first question is x minus 2, modulus of x minus 2 less than 5. Now the sign is less than. Now the different method to solve this modulus function is whenever the sign is less than, the value of this becomes minus 5 to 5. Whenever the sign is less than, the value of this function becomes minus 5 to 5. Now, but we have to find the value of x. So, to find the value of x, we add 2. So this becomes cancelled. So minus 3, x less than 7. So minus 3 to 7. For example, x minus 5 less than 1. Again the sign is less than. So the value of this function becomes minus 1 to 1. So but we have to find the value of x. We add 5. So 5, 5. Cancel. This becomes 4 less than x less than 6. So the class interval is 4 to 6. The third question, modulus of 2x plus 3 less than 15. Again the sign is less than. So the value of this function is minus 15 to 15. Minus 15 to 15. But here we have to find the value of x. So we subtract minus 3. So this one is cancelled out. So minus 18, 2x less than 12. Now in the center there is 2x. So we divided all the intervals by 2. So minus 9 x less than 6. So minus 9 to 6. Now here is fourth example. Again the sign is less than or equals to. So the value of this function is between -3 to 3. But we have to find the value of x. We add 2. So this 2 cancel out. -1 less than or equals to x less than or equals to 5. So the class interval becomes -1 to 5. So we use close brackets because the sign is less than or equals to on both sides. Now the next concept is modulus of x minus 2 greater than or equals to 1. Now the sign is greater than. So in this case there are two options, two cases: x minus 2 greater than or equals to 1 or x minus 2 less than or equals to -1. So please listen it carefully. Whenever the sign is greater than or equals to with the modulus function, so x minus 2 greater than or equals to 1 or x minus 2 less than or equals to -1. So this becomes x greater than or equals to 3. So this becomes 3 to infinity. Now x less than or equals to -1 plus 2, x less than or equals to 1. So minus infinity to 1. The second example of modulus function when the sign is greater than. Now in this question, magnitude of x minus 2 greater than or equals to 5. The sign is greater than. It means either x minus 2 greater than or equals to 5 or x minus 2 less than or equals to -5. So x greater than or equals to 5 plus 2, x greater than or equals to 7. This becomes 7 to infinity. Or x less than or equals to -5 plus 2, x less than or equals to -3. So minus infinity to -3. Now we shift to this question. Again the sign is greater than. 3x plus 2, either 3x plus 2 greater than or equals to 5 or 3x plus 2 or 3x plus 2 less than or equals to -5. So 3x greater than 5 minus 2, 3x greater than 3, x greater than 1, 1 to infinity. Or 3x less than -5 minus 2, x less than or equals to -7, x less than or equals to -7 by 3. So minus infinity to -7 by 3. So this is a concept when the sign is greater than with the modulus function. So in a nutshell, I just recall the previous points regarding the modulus of function. Modulus x equals to 1, then it means x equals to 1 or x equals to -1. If modulus x is greater than 3, the sign is greater than. Whenever the sign is greater than, x greater than or equals to 3 or x equals to x less than or equals to -3. So 3 to infinity or minus infinity to -3. Suppose if x is greater than 10. Now sign is greater than. Either x greater than 10 or x less than -10. So this is 10 to infinity. This is minus infinity to -10. The next concept, modulus x greater than less than 2. Now the sign is less than. Whenever the sign is less than, the value of this function is becomes -2 to 2. So -2, 2. Because whenever the sign is greater than, we always tends away from 0. Whenever the sign is less than, we always tends towards the 0. Now if this is the question, x minus 2 greater than 1. Now either x minus 2 greater than 1 or x minus 2 less than -1. So x is greater than 1 plus 2, x greater than 3, so 3 to infinity. or x less than minus 1 plus 2, x less than 1, so minus infinity to 1. So the total concept of modulus function is totally dependent upon the sign. The sign is greater than or the sign is less than. If the sign is greater than, these are in this way we can solve. If the sign is less than, then the value of modulus function becomes minus 2 to 2. So this is the next question related to modulus function. In this question, first of all, we will shift the plus 1 sign to another side. 4 minus x less than 2. So the sign is less than with the modulus function. Now the sign is less than, so the value of this function is minus 2 to 2. But here we have to find the value of x, so we subtract 4 in all the intervals. So this 4 cancel, minus 6 less than minus x less than minus 2. Now again the sign is minus. We have to eliminate this sign by dividing all the 3 intervals by minus. So this becomes 6. But one thing remember, when we divide the whole equation by minus, this center sign changes. So this becomes 6 greater than x greater than 2. It means 2x less than 6. So the interval is 2 to 6. Again I repeat, whenever you will have to divide or you want to change the sign to another side, the center sign changes. So the less than sign becomes greater than sign, so the interval becomes 2 to 6. So the next question is modulus 3x minus 4 upon 2 less than or equals to 5 upon 12. Now the sign is less than or equals to. So it means 3x minus 4 upon 2. The value of this function is minus 5 upon 12 to 5 upon 12. So how can we find the value of x? So in this case, first of all we will multiply all the intervals by 2. So minus 5 upon 12 into 2, 3x minus 4 into 2, 5 upon 12 into 2. So why we multiply by 2? Because this 2 cancel with this 2. So minus 5 upon 6 less than or equals to 3x minus 4 less than or equals to 5 upon 6. Now we have to find the value of x. So we add 4 in all the intervals. When we add 4, this becomes 6 minus 5 plus 24, cancel out, 3x less than LCM 5 plus 24. So minus 5 plus 24, 19 upon 6, 3x, this becomes 29 upon 6. Now again we divide all the 3 intervals by 3. So 19 into 6 by 3, 3x upon 3, 29 upon 6 into 3. So this 3 cancels. So this becomes 19 upon 18 less than equals to x less than equals to 29 upon 18. So the interval is 19 upon 18, 29 upon 18.